ahead and get started on the support work. The first two problems are stuff that we've done several times. It gives us a function and then tells us to plug in several different things. So it gives me a function, x plus 17. And it wants me to find k of 0, k of negative 13, k of negative 16, k of 7, and k of b plus 1. So again, all we're doing now is just going to this function and replacing the x with whatever's in the parentheses. So I get this part. You do need to have this skill to do what we did today, right? There was a bunch of plugging in, okay? So I'm replacing the x in this time with 0. And then do the math, right? 0 plus 17 gives me 17. So everything is going to look exactly like this one, except this number is just going to change and be whatever's in the parentheses. So this time we have negative 13 plus 17. 4. Do the math. Negative 13 plus 17 is 4. Negative 16 plus 17. You punch that in. Negative 16 plus 17 is 1. Replace it with 7 plus 17, which gives me 24. And then the last one. What am I going to put in this x spot this time? B plus 1. Whatever's in here, right? B plus 1 plus 17. Right, because then you can put the 1 and the 17 together, right? Because they're like terms. I can't do anything with the b, so I'll just bring it over. Plus 18.
So we will put the b plus 18 in there.
That's your answer for that last one, yep. All right, number 2, my function this time is f of x equals 4x squared minus 4x. We're finding f of 0. So we'll do this one, and then there's 2 more that we're going to do. So f of 0, replace both x's with the 0. So I have 4 times, replace x with 0, so I'll have 0 squared minus 4. Again, replace the x with 0. So let's see. 0 squared, still 0. So 4 times 0 minus 4 times 0. What's happening to all this? What's 4 times 0? 0. Minus 4 times 0. 0. 0 minus 0, 0. So then the next one wants me to find f of negative 1. So same function. This time, instead of replacing all those x's with 0s, I'm going to replace them with negative 1s. So 4. Replace my x with negative 1 squared minus 4. Replace the x with negative 1. What is negative 1 squared? That means negative 1 times itself. So negative 1 times negative 1 actually turns that into positive 1, right? Brought the rest down. Now do your multiplication. 4 times 1. 4. what is this? It's a negative times a negative here. So negative 4 times negative 1 actually turns that into plus 4, which gives me 8. And the last part of it wants me to find f of 2. So same exact thing. I'm just going in and replacing all the x's with 2's. So 4 times 2 squared minus 4 times 2. Remember, your order of operations, I need to do my exponent first, right? So 2 squared gives me 4. So this really says 4 times 4. Again, I'm just going to drop the others down. 4 times 4 gives me 16. Minus 4 times 2 is 8. Which gives me 8. Yeah. All right, number 3. Now, these next problems, we're going to be doing a lot of foiling. Actually, I'm going to skip 3. I'm going to do 4 first, and then I'll come back to 3. This got fractions. So I'm going to do 4, then go back to 3. 4 says s minus 3p squared. So this is what is going to give you some practice on that one where we plugged in and we had to do that x plus 4 squared, right? And we kind of did it up here.
Yes.
That's what this is practice for. So s minus 3p squared, it means s minus 3p times itself and then we'll distribute the s to both of those. So let's see, s times s gives me s squared. S times negative 3p. Now, when you, right, the p and the s are just going to hook together. Okay? When I do that, I like to put them in alphabetical order. And that is because on the next step, it's just going to be clearer if the letters are in alphabetical order of a term who is like terms to combine. That kind of makes it clear. It doesn't matter where the p and the s go. You could write sp or ps. It's the same thing. But just to be clearer on the next step, who would be combinable? If you always write your hooked on letters in alphabetical order, then it's easier to see who can go together. So I'm going to write minus 3, and then I'll put the ps. And then I'll do the negative 3p distribute. Negative 3p times s, negative 3, and again, put them in alphabetical order. So see, if you would have written this one as SP, which would have been fine, right, it wouldn't have been as obvious that these two terms are like terms that I'm going to put together in a minute. And then my last, negative 3p times negative 3p gives me positive 9p squared. So now, almost always after you FOIL, after you do this kind of multiplication, well, I shouldn't say almost always, but a lot of times, those two terms will be like terms. Yeah. Which they are in this case. They're both PS's. So I have negative 3 and negative 3 that I'm putting together. Now, I'm not multiplying, so I'm not going to get anything squared, right? You're just putting the PS's all in the same basket. So I've got negative 3 here and negative 3 here. So together, I have negative 6 of them. So I bring down my s squared, negative 6 PS's plus 9p squared. All right, now I'm going to go back to number 3. 4c plus 1/5 squared. See why I skipped it? So if I square it, that means to multiply the 4c plus 1/5 times itself. Yep. So let's see, what do I have first? I've got 4c times 4c, which gives me 16cc, or c squared. But then what do I have? 4c times positive 1/5. Okay? It's not too bad to multiply fractions because you just go straight across on top and bottom. But remember, your calculator will do that. What do I need to multiply in my calculator? The 4 times 1/5. We'll just tell it that. 4 times 1 divided by 5, right? That's how you're going to make it. There's your decimal. Doesn't want the decimal though, right?
Nope.
What do you do to that?
Math, enter, enter.
Math, enter, enter, which gives you 4 over 5. So I've got 4c times 1/5. What does that give me? 4 over 5 what?
C.
4 over 5 c. One-fifth times 4. Well, that's what I just did, right?
Right.
1/5 times 4. So what did that give me?
Positive 4 over 5C.
4 over 5c again. And what's the last thing you have to do? 1/5 times 1/5. If you want to do that in your calculator, I'm going to do this. So I'm just going to show you that it's not too bad to do 1/5 times 1/5. Because when you're multiplying fractions, you simply just go straight across in the top and straight across in the bottom, which gives me 1 over 25. Oh, hang on. I think that's a wrong symbol. I think, yeah, use this. 1 over 5. So let's see, who goes together here? Your C's that are in the middle, right?
Mm-hmm.
So let's see, I need to add those together.
8 over 5.
Right, so 16c squared, 4/5 plus 4/5. Now you're adding, which means you're not going straight across from top and the bottom. You have the same denominator, which is good.
Right.
So you just add those numerators together. So that's going to give you plus 8/5 c
Squared.
not squared, just c, right?
Okay.
Because I'm not multiplying.
Okay.
That is the most common mistake. I'm just putting these all in the same basket. That doesn't make them squared. You only get squared when you're multiplying. Bring down the plus 1/25. All right, number 5. Two b squared minus 4g squared squared. So if I'm squaring that parenthesis, that means I need to multiply that parenthesis times itself. So I've got 2b squared minus 4g squared times, just repeat it, 2b squared minus 4g squared. So
4b to the 4th power.
Right, good. Because what am I doing first? 2b squared times 2b squared gives me 4. And then your b squared, you add those exponents together. So you're going to have 4. Then b squared gives you b to the 4th. Then where are you going?
Negative 8bg to the 4th power.
Hang on, because there's a little trick on this one. I've got 2b squared times negative 4g squared. So let's see, gives me negative 8. Now, I've got a b squared and a g squared. You don't add those exponents together because they're not the same letter.
Gotcha. So they just stay squared.
They just stay squared. So you're going to have, and put them in alphabetical order. A b squared times a g squared is just b squared, g squared. And here. Negative 8 again. I've got a g squared, b squared. They're not the same letter. So it's just going to, I'll put them in alphabetical order. B squared, g squared. And then the last one.
I have a positive 16.
Positive 16.
G to the 4th.
They are the same letter now, right? G squared times g squared. That means I do add their exponents to get me to 4. Look at these terms in the middle. They're both b squared, g squareds, which means they're the same.
Negative 16.
So put them together. Negative 8 and negative 8. You are right. Gives me all together, I have negative 16 b squared, g squareds. And then bring down the 4b to the 4th plus the 16g to the 4th.
So you don't add squares, you just bring them down. But you got the b squared, so you don't do
This one? Yeah. So the reason that when I multiplied this times this, it gave me b to the 4th is because I was multiplying. Now on this step, I'm not multiplying those two things together. I'm adding them, or I guess in this case, subtracting. I'm really questioning the saying. We're not even going to get through. All right, number 6. I've got 5 plus 3/4 over 5 minus 4/7. Okay, I'm going to try to work this page as similar to each other as I can. There's several different ways to do these, but one way is to go by the rule that the actual definition of division means to multiply by the reciprocal, and the reciprocal means to flip it upside down. So what that means is if I can get the top and the bottom to be one term by just adding that together and subtracting that, then I'm going to use that multiplying by the reciprocal rule that division is. So what I need to do first is see what 5 plus 3/4 is. I'm going to do it with my calculator. 5 plus 3/4. So 3 divided by 4.
23/4.
All right, it's going to give me a crazy decimal, which means I will enter that. So when I add 5 to 3/4, it gives me 23/4. I'm going to do the same thing down here. So 5 minus 4/7. So 5 minus 4/7. And again, math. Enter that. 31/7. Now I could type that in my calculator just like that. right? If I did that, I would put a parenthesis around both of those and put a division symbol between them. But what was I just saying? What is the definition of division? It means to multiply by the reciprocal. That means to do the top
4 over 23.
times flip the bottom.
7 over 31.
So instead of dividing by 31 over 7, I am multiplying by its reciprocal. Now remember, multiplying fractions is the easy kind, right? You just go straight across from top and bottom. So up top, I have 23 times 7. Which gives me 161. 4 times 31 in the bottom gives me 124. And then I just want to double check to make sure that's in simplest form, which means I need to type that fraction in and math enter it. If it is reducible, your calculator will reduce that. 161 divided by 124. There's my decimal.
And it is.
Math enter. And what did it tell you? It still told you 161 over 124, which just means that's in its simplest form. Right, number 7. Same exact kind of problem. Three-fourths plus 1/3 over 11/12 minus 5/8. So what I'm going to do is add the fractions in the top and turn it into just one number. Subtract in here. Turn that into one number. And then do the multiply by the reciprocal. The top times the reciprocal of the bottom. So 3/4 plus 1/3. How much is it? No, that's only in multiplying.
Oh.
Multiplying, you go straight across from top and bottom. Adding and subtracting, you have to get a common denominator and all that. That's why I just punch it in my calculator.
13, 12.
So 3/4 plus 1/3. So just 3/4 plus 1/3. Crazy decimal, math, enter it. 13/12. Same thing here, 11/12 minus 11/12 minus 5/8. And math, enter that to get 7/24. So now I have one fraction over one fraction, which means now I can multiply by the reciprocal. So I've got 13/12 times, flip the bottom to 24/7. Now is when you go, because now I am multiplying, so I can go straight across top and bottom. So 13 times 24. 312, 12 times 7.
84.
84. And then just make sure to see, does that reduce or not? So 312 divided by 84 gives me 3.7 something.
26 over 7.
And then math, enter it, which is a very helpful thing, right? Because I don't know about looking at that right now if it reduces, right? So that reduced it to 26 over 7. All right, number 8, I'm going to use the same rules that I'm using here. I don't even have to do the first step because it already is one fraction over one fraction. Just letters. X squared over y to the 7th over y to the third over x to the sixth. So on this one, I don't even have, this already is just one fraction. Now remember on the last one, I had 2 fractions that I had to add together up there. I don't have to do that step. There's not 2 separate fractions that I need to add together. There's not 2 separate fractions that I need to add or subtract down here. So it's like I'm already to the next step, which was what? Turn the division into multiplying by the reciprocal. We're already to that step now. So I have x squared over y to the 7th times, flip this one. So it'll be x to the 6th over y to the 3rd. Right, so I just turn the division into multiplication and I flip the bottom fraction. Now I'm multiplying, just like always, straight across from top and bottom. What do you do when you're multiplying the same letters? You add
the exponents.
Good, 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 good. So that gives me x to the 8th over y to the 10th.
Yeah.
All right. Number 9. I've got 25a squared minus b squared over ab over 5a plus b over a. Cool. So on this one, I do actually have, there's nothing I can add together up here, right? It's all one fraction. It's not a pretty fraction. Same thing here. There's nothing to add together. This is all one fraction. So I'm going to go ahead and jump to this part where I multiply by the reciprocal. This one gets out of control because I've got 25 a squared minus b squared over ab times, so I turn the division, which means I will flip this, a over 5a plus b. Now, here's something that is in this. You probably did a lot of this if you took transitional, but probably none of y'all took transitional, I would think. So you did a lot of factoring. Actually, you did factoring in foundations too, if you did foundations. This was what was called a difference of perfect squares. So when I factored this was probably towards the end of foundations, okay? What I want to do is anytime you're multiplying fractions like this, everything has to be in what's called its factored form, because then you're going to be able to do some canceling. Now, this is a difference of perfect squares. So if I wrote this in its factored form, it would have 2 factors. What I mean by they're perfect squares is there is something, if I was foiling here, there is something times exactly itself that gives you 25a squared. What can I put in both of these spots? It's going to be the same exact thing. And I'm going to multiply them, and it's going to be 25a squared. What's the same number? 5? Good. 5 and 5 will give you the 25. A and A will give you that a squared. So that'll give you 25a squared. Now, this last term have to multiply to give you b squared. What are you going to multiply times itself to? What do you do? What times what is b squared? B times b. 1b times 1b.
Okay.
In your difference of perfect squares are always different. 1 plus and 1 minus, and it doesn't matter which way they go. Stay with me. This is one of those that don't know where it came from. So now I don't have this. It turned into this. If one of these factors I also see in the denominator, it'll cancel it. Which one of these factors do you see in the denominator of one of your fractions? That 5a plus b can cancel that one. I also see this a can cancel this a. Then your answer is essentially what is left. I canceled the 5a plus b and the a. So the only thing that's left in your numerator is 5a minus b
over b.
Only thing that's left in the denominator, since that a and all that canceled, the only thing that's left is the b. That's your answer.
Interesting.
No.
All right, number 10. 10 and 11 are the last ones that I have that are like these. It looks like the last problems are FOIL. And I feel like we're a little better at FOIL than, or it seems a little more straightforward. All right, 10, 1 over y plus 8 over 1 over y minus 9. These are the problems that this one is really the one that I think benefits you in figuring out the college algebra work that we did. Remember when we had, because I can't add these two terms together. I can't turn it into one fraction because this is a y and that's not. So what did we multiply the top and the bottom by to cancel out whatever the denominator is? So look what's going to happen. I'm going to multiply the top and the bottom by y. So since this one has a y in the bottom, they kind of cancel each other out. So here's what I'm doing here. So those y's would cancel, so I'd just be left with that 1 plus, what's y times 8?
8y.
8y. And the same thing in the bottom. The y goes to both of these. So again, it cancels the y in the bottom here. So I'm just left with that 1 minus y times 9, 9y. And that's your answer. That's what we did in the work today, right? We used the denominator to help us cancel. Oh, good. Same thing. What am I going to multiply the top and the bottom by? What's going to cancel out these u's? So multiply the top and the bottom by u. So up top, u goes to u. What do you get there? You multiply u squared. And then here's why I used it, right? Because it cancels out the bottom u. So I just have minus 1.
Oh, yeah.
Right? Yeah, because that one canceled that one. Do the same thing in the bottom. This one goes to both of those. U times u again gives me u squared plus, good, this u cancels that one. So you're just left with 1. That's it. Let me get through it. All right, the last problems are all FOIL kind of problems, but look what they have in them. Square roots. the rule for when you're multiplying square roots, let me just do this before we get to that. If you had the square root of 3 times the square root of 3, if they're both underneath the square root symbol, you multiply the 3 together to get the square root of 9. And then you would simplify that because what is the square root of 9? 3. It's 3. All right, what does that mean by square root? That means what number times itself is that? Okay, now this is different. When you're multiplying square roots, you multiply the numbers that are in front of the square roots together. So I would have, what would that give me? What would that give me in front of my square root?
8.
8.
8.
Good, 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 good. And then you multiply, just like I did up here, whatever's underneath here together and put it under one square root. So what?
30.
So square root.
30.
Good. So that's the rule on multiplying square roots. Okay, so we're about to do a bunch of these in the FOIL. So if they're under the square root together, you multiply them together. And if they're in front of the square root, you multiply them together. So let's look at 12. You have the square root of 8 minus the square root of 3 times the square root of 8 plus the square root of 3. So I'm going to FOIL this. So the square root of 8 goes to both of these. So let's see, what do I have here? Square root of 8 times the square root of 8.
64.
So that gives me this, and they're both, it's under square root, right? Square root of 64. Then what do I have out here? The square root of 8 plus the square root of 3. They're both under square roots, so multiply the 8 and the 3 together. What's that going to give me? Plus 24.
Plus 20.
And distribute this one. Negative. Multiply them together. 3 times 8 gives me negative square root of 24. And then my last negative times a positive gives me negative
9.
square root of 9. So now, after we multiply, we look for anything we can simplify or put together.
The 24
All right, what happens to those?
They cancel.
Right, one's positive,
Cancel it out.
negative. So they're going to cancel each other out, right? If you have the positive and the negative of the same thing, doesn't matter what they are, they're going to cancel each other out if they're exactly the same with different signs. What's the square root of 64? Does that simplify? Is there a number times exactly itself that is 64?
8.
8.
That's just plain 8. Minus, what's that one?
3.
Plain 3. So now I'm left with 8 minus 3. Can I do that? Yeah, it's plain 8 minus plain 3, which is plain 5.
5.
All right, just a couple more. Number 13. 4 plus 6 square root of 3 times 4 minus 6 square root of 3. Four times 4, 16. Okay, now I have 4 times negative 6 square root of 3. Is this 4 under a square root?
No.
No. Then it multiplies with the part of this that is not under a square root.
So you got negative 24.
So you're going to have negative 24 with a square root of 3, right? Think about if this was 4 times negative 6. What if that was an x? What would you have? 4 times negative 6x would give you what? negative 24x. It's the same concept. 4 times negative 6 square root of 3. This gives me negative 24 square root of 3. So what's this one going to give me? Positive
24
square root of 3. And then the last part, multiply the numbers that are in front of the square roots together. So that'll give me positive 6 times negative 6.
36.
Negative 36. And multiply the square roots together. Since they both have a square root of 3, I'll multiply those 3's together to get the square root of 9. Now I've got some work to do. First thing I'm going to do, though, is
Cancel out.
get rid of all that. Right? Positive and negative are the same thing. That and that goes all the way away. I can't do anything with a 16, right? It's not a square root of 16. It's just a plain 16. So I'm just going to bring it down. But I can do some work here because what is this? How much is the square root of 9? What is that?
3.
It's 3. So this really says what? Negative 36
square root
times 3, right? This is this, right? Square root of 9 is 3. So what is that? What is negative 36 times 3 gives me negative 108. So all of this turns into minus 108. And can I do that? What is 16 minus 108? I don't know, but I'm not going to punch it in, right? 16 minus 108 gives me negative 92. All right, 2 more. 6 plus the square root of 6 squared. So when I square that parentheses, that means to multiply it twice. So same thing I did on the last one. 6 times 6 gives me 36. Then what do you have here though? Is the one of them's in the square root, but one of them's not. So I don't multiply those 6's together, right? 6 times the square root. What if this was an x? What would you get? 6 times x would be 6x. Same concept. 6 times the square root of 6. 6. Square root of 6.
And you've got the same thing.
Right. Square root of 6 times 6.
6
is another 6. Square root of 6. But what happens to this one? Are those both in square roots?
Yes.
Then you multiply those 6's together. Square root of 6 times the square root of 6 is plus square root of 36. Right? Okay, so first 6 times 6, that's what gave me this. Is the 6 to the square root of 6. So it's like an X. That means they just hooked on. So that gave me 6 square root of 6. Then on the inside, same thing. Square root of 6 times 6 gives me another 6 square root of 6.
Okay.
And then the last, this time I did multiply the 6's together because they were both in square roots. Okay, so let's see. I can't do anything with this 36. I'm just going to bring it
down.
But
you're going to add.
Cancel out.
Opposite, those don't cancel this time, right?
Nope.
Because they are set like terms. They're both square roots of 6's, which means I can put them in the same basket. If you've got 6 of something and you have 6 more of that same exact thing, how many square roots of 6s do you have?
36.
Not
You got 12.
Adam, you've got 12 of them,
Yeah.
right? So if I put these two terms together, since they're both square roots of 6, I've actually got 12 square roots of 6 altogether.
Okay, so you wouldn't multiply inside.
Right, because I'm not multiplying anymore. Now I'm to the point where I'm just putting the same
Gotcha.
terms together.
Okay, that makes sense.
Plus,
36.
who's that? What is? How much is that really?
Square root of the 36?
What is it? What is the square root of 36?
Oh my gosh.
6.
Times itself is the
6.
6.
right.
Yeah, 6.
So now that I've turned that into a plain number, who can this go with?
36, which is 42.
Right, I can put those together. Good. I don't know who said that, but that's good. Right here, 36 and 6, you can put those two together because they're both the same kind of term. They're both just plain numbers. So when I put that together, I get 42.
Plus
And then just
12.
And leave the square root of, yeah, okay.
Good, because I leave it just like that. How come I can't add that 12 and that 42 together?
Because it's hooked onto the.
That's not just a 12. It's hooked on to the square root of 6, which makes it not the same kind of term as that. You can only put square roots of 6s with other square roots of 6s. Okay? All right, 15, last one. It's almost the same exact problem as this. The only thing that they changed was this right here. 6 plus the square root of 7 squared. So same exact steps. This is our last problem. Thank the Lord, right? I'm done with this. So let's see. 6 plus the square root of 7. Multiply it times itself.
You're going to have 36 again.
Right. So the 6 goes to the 6, which makes it
36.
36.
You're going to have 6 to the square root of 7.
Right. So again, what happens to this 6 when I multiply it times the square root of 7? They just hook together.
Yeah.
Right? Just like if it was an x. 6 times the square root of 7 is 6 square roots of 7.
Probably it's going to do the same thing. It's going to be plus 6 square root of 7.
Another good 6 square root of 7. And then my last, those are both under square roots. So I am going to multiply those 7s together. What's that going to give me? The square root of
49.
49. And just like the last one, I can put those together, right? They are the same kind of term. They are both square roots of 7.
So it's 12 to the square root of 7.
Right. I've got 12 of them, actually. Instead of 6 here and 6 here, just put them together. I actually have 12 square roots of 7. Just bring down this 36. Who's this, though? What does that turn into?
7.
7. So I have plus 7, which means who can this 7 go with?
The 36.
That 36. What is that? 43? So I have 43 and then plus 12 square root of 7. Woo!
Whoa!
That was good.
That is it. So hopefully Wednesday will go a little bit lighter on us.
Good job, teacher.
Oh, good job, y'all. That's a lot to get through in one day. That's a
It was, but it was great. It was good.
good. All right, I'll see y'all Wednesday.
Have a good day.
Call them, baby.